Arithmetic Review, Integers, Part 3. Alright, let's jump straight ahead and cover the final operator, division. When you take an integer a and divide it by an integer b, where b is a divisor, also known as a factor, of a, the result is always a divisor of a. For example, when 60 is divided by 6, one of its divisors, the result is 10, which is another divisor or factor of 60. Now where it gets interesting is when b is not a divisor of a. In this case, the result can be viewed in three different ways. It can be viewed as a fraction, as a decimal, or the result can be viewed as a quotient with a remainder, where both the quotient and remainder are integers. Fractions and decimals are useful when the result must be viewed as a single number, while quotients with remainders are useful for describing the result in terms of integers only. Since we are reviewing integers in this video, it's natural to talk about them first. We will discuss fractions and decimals in a later video. For now, let's discuss the third view, division as a quotient with a remainder. Say I have the integer 13, and I want to divide it by 5. Notice that it won't divide evenly with 5. You can also think about this in the following way. Pretend you have $13, and you're trying to divide this amount among 5 people. At least each person will receive $2, and you will have $3 remaining. We can express the number 13 by using the quotient, in this case 2, and its remainder, as follows. 13 is equal to 2 times 5 plus 3. Hence, the result of 13 divided by 5 is the quotient 2, or simply as 2 remainder 3. In general, when a positive integer, say a, is divided by a positive integer, b, you first find the greatest multiple of b that is less than or equal to a. This particular multiple can be expressed as qb, where q is the quotient, and the remainder is equal to a minus that multiple of b. Notice that the remainder r is always greater than or equal to 0, and less than b. For example, 100 divided by 45 is 2 remainder 10, since the greatest multiple of 45 that's less than or equal to 100 is 2 times 45, or 90, which is 10 less than 100. In the next example, 24 divided by 4 is 6 remainder 0, since the greatest multiple of 4 that's less than or equal to 24 is 24 itself, which is 0 less than 24. The fact that we got a remainder of 0 means that 4 is a divisor or factor of 24. How about the following division? 6 divided by 24 is 0 remainder 6, since the greatest multiple of 24 that's less than or equal to 6 is 0 times 24, or 0, which is 6 less than 6. These are the three distinct cases when dealing with divisions involving quotients and remainders. Let's do one more of each type just to make sure you understand this. Let's try 100 divided by 3. This will be equal to 33 remainder 1, since 100 divided by 3 goes evenly 33 times. So we take 33, multiply it by 3, then we add 1 to the product, to write it as 100 is equal to 33 times 3 plus 1. Let's try the second case. 100 divided by 25 is 4 remainder 0, since 100 divided by 4 goes evenly 4 times. So we take 4 and multiply it by 25, and obtain 100. So there's no need to add a remainder. In this particular case, the remainder is 0. So 100 is written as 4 times 25 plus 0. And finally, the third case, 100 divided by 150 is 0 remainder 100, since 100 divided by 150 goes evenly 0 times. So 0 times 150 is equal to 0, so we need to add 100, which itself represents the remainder. So 100 is written as 0 times 150 plus 100. Alright, now let's talk about divisibility of integers. Here are some rules to help you determine if a number is divisible by a certain integer. An integer is divisible by 2 if its units digit is divisible by 2. For example, we know just by glancing at it that 1,562,158 is divisible by 2, because the units digit 8 is divisible by 2. Likewise, the integer 786 is also divisible by 2, because the unit digit 6 is divisible by 2. An integer is divisible by 3 if the sum of its digits is divisible by 3. For example, we know that 5,616 is divisible by 3, because the sum of its digits, 5 plus 6 plus 1 plus 6 equals 18, which is divisible by 3. Also, we can add the digits of 18 as 1 plus 8, which is equal to 9, which is also divisible by 3. An integer is divisible by 4 if its last two digits form a number that's divisible by 4. For example, 712 is divisible by 4 because the last two digits 12 is divisible by 4. Likewise, the integer 358,916 is divisible by 4 because the last two digits 16 are divisible by 4. An integer is divisible by 5 if its units digit is either 0 or 5, like in 105 or 20,180. An integer is divisible by 6 if it's divisible by both 2 and 3, like in 204. This integer is divisible by 2 because its units digit is 4, and is divisible by 3 because the sum of its digits, 2 plus 0 plus 4 equals 6, which is divisible by 3. Hence, the integer 204 is divisible by 6. An integer is divisible by 9 if the sum of its digits is divisible by 9, like in the number 61,326. If we add the digits 6 plus 1 plus 3 plus 2 plus 6, we obtain 18, which is divisible by 9. And finally, an integer is divisible by 10 if its units digit is 0, like in the number 100 or 145,890. Rules for divisibility by 7 and 8 do exist, but are too complicated and not worth memorizing. Nevertheless, they do exist. Alright, in our next video we will focus on the concepts and terminology that are associated with special integers.